Our last topic in this section has to deal with the shapes of distributions. This particular topic actually recurs throughout the course, so this is going to be an important idea, but luckily it's not too difficult of a concept. Namely, there are four particular shapes that we are interested in. So there's the uniform shape. The uniform shape means that roughly everything is basically the same. It's symmetric, but it also means that 7, 2, 8, 3, they're all basically the same height. So the frequency is roughly the same for each. In other words, it's evenly spread throughout. Now the bell-shaped distribution has the highest frequency in the middle and the tails going off to the side. So it looks roughly like this, which is a curve you may have seen before called the bell curve. So that bell curve is a very important curve to us. It's also called, there are other distributions that have that shape, but if you've ever heard of the normal distribution, that's what we're talking about. And boy, will you hear about the normal distribution in this course, I promise. So it goes up and goes back down. And it has two tails, a tail over here on the left and a tail over here on the right. So the frequencies tail off, see? Tail off. So you have a tail here and a tail here. All right, now a skewed right distribution, it's skewed right. It's also known as positively skewed. Now the reason it's positive is because on the x-axis, which is what this is, if you remember here, draw your little x-axis. So here's the x-axis, right, with the number line, right? So if that's the x-axis, then over here is the positive side and over here is the negative side, right? And here's 0 in the middle. So they call it positively skewed or right skewed because the tail is towards the larger values. So here's the tail. See how it's tailing off over to the right? That's right skewed. It's where the tail is, not where the bulk is, but where the tail is that makes it skewed. So this is skewed right or skewed positively or positively skewed. By the same token, negatively skewed is towards the negative side, right? So it's towards the left. So skewed left is the words we use most often, but it's also known as negatively skewed, not because the values are negative, but because that direction on the number line is negative, right? So this to the left is negative, to the right is positive. And since we have a tail over here to the left, it's negatively skewed or skewed left. And again, this is negative, this is positive. So this one's skewed right or skewed positively. Right? It has to do with this is an x-axis. The same x-axis you know and love from algebra class, or maybe hate from algebra class. All right, now there are a few things to keep in mind. If you look at, well, let's just go to the next example and you'll see. It is not possible to determine the shapes for bar graphs as the ones below because the x-axis is in words. Now, if you look back here at all of these ones, they all have numbers. Now, technically, their bars should touch. I wasn't able to when I was making these notes. Maybe I'll fix that for future. But the bars should be touching right here. See, like that? These are numbers. They're quantitative data. So you could make a note that the shapes of these distributions, shapes are only valid. That's why we didn't learn this in section 2.1, because section 2.1 was about qualitative data, and these are only valued for quantitative data. Numbers, right? It has to be numbers, and it has to be numbers with meaning. Social security numbers don't count, right? We learned that a while ago. Same thing with like zip codes and area codes and stuff like that. Those don't count. It has to be numbers we can do meaningful calculations from. So numbers with, I'll even say that, meaningful calculations, right? That's what quantitative data is. It has meaningful calculations possible. So that next comment is saying, hey, you can't do this if the x-axis is qualitative because then they're words. When they're numbers, you know 2, 3, 4, there's an order. There's a rank order to those numbers. But when I do them over here with Japan, Germany, Canada, France, and so on, you might say, oh, that's skewed left. Oh, no, no, no. There is no inherent order to those words. I could completely re-alphabetize them in a different way, and that wouldn't show that shape at all, right? But you can't do that with numbers. Numbers have to be, this is the x-axis, right? This is number 2, number 3, number 4. That is not the case over here. See the difference? So because the x-axis is words, so qualitative data cannot have a shape. Because there's no rank order to words. That's what makes it nominal or qualitative data. They cannot have shapes because you could just rearrange them anytime you want, which you cannot do with numbers. All right, now let's think about exams for a moment. Which of these would we say is most likely for the exam scores in a math class, and explain why? I'll do one better. Which one's most likely for the scores of the ACT? So let's do exam scores in a math class. Let's do that as A. And let's do ACT exam scores. I'll add this for future. Because one of them is likely for ACT exam scores. And we'll call that B. Now, which one is which? Well, if you think about the count and the numbers we actually already saw for real legit exam scores, I think you might be able to see kind of a sense here. These were real final exam scores for a math course. And you can actually tell the distribution shape without even looking at a graph here. Look at these ones. See how tall these bars are? So the tall bars are on the high values. And you have very small bars down here on the low values. So this is the tail. So it's skewed left. So looking at these distributions, it's this one, right? Class 4, that is the exam scores on a math class, right? So this one right here, this is A. Exam scores on a math class. Are most likely skewed left, right? So most people score up here, only a few people down on the low side. We actually already saw that in the real data set. So see example 2's table, right? Because you can actually tell it from a table without even seeing from a graph that it's skewed left. Now, what about the ACT? The ACT is actually this one. So this is letter B, the ACT. And what they'll tell you when you take the ACT is that it's a, quote, normalized test. They'll tell you that they do that. Or standardized, that's another word they'll use. What that means is that they make it and they design it so that it has this distribution. If it's a standardized test, it means it's designed to have this kind of shape. Very few people on the very highest end, but also very few people on the lowest end, and most people in the middle. The ACT is like that. The SAT is like that. The IQ test is like that. Lots of tests are standardized or normalized, and they will have this shape to them. And one last word about shape. This is bell-shaped right here. This is skewed right. This is skewed left. This is actually a U shape, which isn't a shape that we talk about in our class very much, but it's a U shape. Let's hope we're not in a class like that. That would be not so good. And especially not in a class like this one. That would be really not good, right? So skewed right, skewed left, bell-shaped, and U-shaped if you're interested, but we won't really use that one